Hello everyone. Today we're going to take a look at how to multiply and divide scientific notation. But first, let's review going from scientific notation to standard form and also standard form back to scientific notation. So let's take a look at number 1. So I'm going to give you 4.2 times 10 to the negative 5 power. So we want to write this in standard notation or standard form. So several things that are important. First, you write the number that's in front of the times 10, so 4.2. Next, we want to look at our exponent. Our exponent on the 10 here is negative 5. Remember, a negative exponent means this is a small number, so my decimal needs to be moved to the left. Negative is to the left. 1, 2, 3, 4, 5. Fill in your dips with zeros, so my answer in standard form is 0.1234 zeros and then 42. Let's do another one. So let's say I give you 6 times 10 to the third power, and I want you to write that in standard form. So the first thing you do is you write the number in front of the times 10, and in that case it's 6. Find your decimal. If there's no decimal, remember it's at the end, okay? So 6 point is my number right now. Look at your exponent. I have an exponent of positive 3. Positive exponents mean I have a big number. Positive is to the right, 3 spaces. 1, 2, 3. 1, 2, 3. So my new number, or my number in standard form, is 6,000. Now let's go the other way. Let's say I give you this number right here, let's write 4 zeros. 1, 2, 3, 4, 48. And I want you to write that in scientific notation. So first, we find our decimal. Then we mark where we want our decimal to go. Remember, we want a 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of the decimal. So in this case, I'm going to have 4 in front of the decimal. So my number is going to be 4.8 times 10 is always a part of scientific notation. And I moved 1, 2, 3, 4, 5, and it was a really small number. My decimal started off to the left, so that's why it's a negative 5. Let's do one more. Let's say we have 3 million, or 3 billion, I'm sorry. Yep, 3 million. And I want to write that in scientific notation. Find your decimal. If you don't see it, it's at the end. Where do you want to put your decimal? You want 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of the decimal, so here I have 3. So I have 3 times 10, and I moved 1, 2, 3, 4, 5, 6 spaces, and it is a large number. The zeros are to the right of the number, so that's why I have a positive 6. Now let's talk about how to multiply. First we'll do multiplying, scientific notation. So here's our first example. We have 3 times 10 to the negative 6 power times 3 times 10 to the 9th power. So we're going to put together some stuff that we already know to help us do this. So watch this. First of all, I'm going to multiply my numbers up front. So I have 3 times 3, and then times, I'm going to multiply my 10 powers. So I have 10 to the negative 6 times 10 to the 9th. Don't get thrown off because I'm writing parentheses. That is actually going to be our product rule. So that's my next point. Next, you multiply the numbers up front. 3 times 3 is 9 times. Now let's use the product rule to combine our 10 powers. So I keep the base, and the product rule says you add the exponents. So what is negative 6 plus 9? It's positive 3. So the answer is 9 times 10 to the third power. Let's try another one, number 6. So I want us to do 1.3 times 10 to the negative 4th power times 4.2 times 10 to the 11th power. So let's split this up into two multiplication problems. So first I want to do 1.3 times 4.2 times, and I'm going to do my 10 powers, 10 to the negative 4th times 10 to the 11th. I'm going to go ahead first and simplify my 10s. So the product rule says keep the base, add the exponents. Negative 4 plus 11. The signs are different, so we actually subtract, but negative 4 plus 11 is 10 to the, let me think here. Yep, 7th. I want to make sure my math's right. Now I have to multiply my other numbers. So I'm going to have to do a little bit of side work here. So I'm going to have to do 1.3 times 4.2. Now, your strategy for multiplying decimals may be different from mine, just as long as we get the same answer. The way I do it is I do 2 times 3 is 6, 2 times 1 is 2. Now, I've multiplied by 2, so now 4 times 3 is 12. Put down the 2, carry the 1. 4 times 1 is 4, plus 1 is 5. And then I add those 6, 4, 5. But then I have to do my decimals. 1, 2, 1, 2. So my answer is 5.46 times 10 to the 7th power. So that's how you multiply scientific notation. Now let's take a look at how we divide numbers that are in scientific notation. Number 7, we're going to divide 1.8 times 10 to the 13th power divided by 3 times 10 to the 8th power. So, just like we multiplied, we broke it into two separate problems, we're going to, when we divide, break this into two separate problems. So, watch this. I'm going to do 1.8 divided by 3. So, I went ahead and set it up this way. So, I can, let me use my line here. 1.8 divided by 3, so I can do my work, times, because, you know, all scientific notation is times 10, times 10, well, let's go ahead and just do it this way, times 10. When we had the quotient rule, how did we get our exponent? We subtracted, right? So what is 13 take away 8? Well, 13 take away 8 is 5. So I'll go ahead and write that down, times 10 to the 5th power. That takes care of that. Now let's do this division. How many times will 3 go into 1? It won't. I do need to bring my decimal up. And then, how many times will 3 go into 18? 6. 6 times 3 is 18. So that is my answer. Now I want you to take a look at this. I have 0.6 times 10 to the 5th power. Is that in scientific notation? Just because it has a times 10 to the 5th power doesn't mean it's in scientific notation. Because remember, we have to have a 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of the decimal. So what I have to do is I have to fix this. So I'm going to do 0.6, and I'm going to move my decimal 5 spaces to the right. So I'm going to expand this. 1, 2, 3, 4, 5. 1, 2, 3, 4. So I end up with this number, 1, 2, 3, 4, 1, 2, 3, 4, right here, 60,000. Now I can write it in the proper scientific notation. My decimal is here. I want to move it here. So this becomes 6 times 10 to the 1, 2, 3, positive 4th power. So when I divide or multiply, I always want to make sure my answer is in proper scientific notation. Okay? This can happen on multiplication problems as well. It just so happened to be on a division problem here. All right, so now let's go through those division steps again. Let's try one more problem together. So I want you to divide, or us to divide, 55 times 10 to the 5th power by 1.1 times 10 to the second power. So we're going to split that into two math problems. The first one is 55 divided by 1.1, times 10 to the, remember your quotient rule says subtract your exponents, so I'm going to do 5 take away 2. So I'm going to go ahead and write my times 10 to the, what is 5 minus 2? It's 3. Now let's divide 55 by 1.1. Well, I can't divide by 1.1. So I'm going to, if you'll remember from 6th grade, move my decimal one space to the right, but I also have to do that here. So I move one space to the right, add a 0, and bring up my decimal. Now I can divide by 11. 11 goes into 5 0 times, but 11 goes into 55 5 times. 5 times 11 is 55. Bring down your 0. How many times does 11 go into 0? Well, 0 times. 0 times 11 is 0. So my answer here is 50. And guys, here's another example. Is 50 times 10 to the third power in the correct scientific notation? No, it's not. So I need to change this and rewrite it. So this is 50, my decimal is here, times 3 to the third power. Positive 3 is to the right, 1, 2, 3. So my new number is 50,000. Now I want to rewrite it in scientific notation. So my decimal is here, but I want it here. So 5 times 10 to the 1, 2, 3, 4. My numbers are to the, my zeros are to the right, or it's a big number. So 5 times 10 to the fourth power is the answer to my division problem.